Rahim. Assalamu alaikum dear students. This is our next problem having been chosen from the book Modern Physics by Stephen T. Thornton and Andrew Rex. As usual, we first come to its statement. Okay, calculate the momentum, kinetic energy and total energy of an electron traveling at a speed of part A 0.20 c, that is to say about 2% of the speed of light. Part B 0.20 c, that is to say about 20% of the speed of light. Part C 0.90 c, that is to say about 90% of the speed of light, where speed of light is 3 into 10 raised to the power 8 meter per second. Okay. Yes, students, similar problem might have been solved in the book of Paul Tipler or Kenneth S. Crane, but now we are following the book of Stephen T. Thornton and Andrew Rex. Okay, so it is confirmed, it is clear that no problem is being repeated throughout this channel. Okay, now we are going to its solution. Before starting our solution in a formal manner, we are going to introduce various snapshots. Okay, because these snapshots have been previously included in our previous lectures, so we will not go in detail of these snapshots, and we will just include these snapshots in this lecture. Okay, first snapshot is about Lorentz factor gamma, already included. Second snapshot is about total energy of a particle. Okay, that is to say kinetic plus rest. Third snapshot is about relativistic momentum. Fourth snapshot is about relativistic kinetic energy. Okay, that is to say total energy is equal to kinetic energy plus rest energy. Relativistic kinetic energy plus rest energy. Okay. Next, there is a table of physical constants. This table has also been included several times in our previous problems, so it will not be discussed in detail. Okay. From this table, we may be able to use this value of speed of light. Moreover, electron mass 0.511 million electron volt over c square. Moreover, perhaps this is this table is also almost contained in the above table. Anyhow, now we come to its solution in a formal manner. Okay, dear students, this problem has three parts, A, B, C, and solution methodology of all the three parts is 100% same. That is why we will not give much time to part B and C. Okay, actually the practice adopted here is that first I solved only part A of this problem in math type, and then copied pasted in Word file. Okay, then I took that material again and copied pasted from Word to math type and made relevant changes, and then once again cut paste and shifted to Word. Okay, so here copy paste has worked a lot, because otherwise the problem is enough lengthy. But due to copy paste facility, it has become easier to type this lecture. Okay, we come to part A. We know that the relativistic momentum for a particle of mass m moving with velocity v is given as relativistic momentum P is equal to mv over 1 minus v square over c square, using v equal to 0.02 0 c and m equal to me, where e is written as a subscript of m, that is to say mass of electron equal to 0.511 million electron volt over c square. In equation number 1 we get what we get momentum, relativistic momentum p equal to mv over 1 v square over c square. This becomes, we have just put values and then simplified. Okay, here c square will be cancelled out with c square. Okay, moreover 1 c will be cancelled out from this, and only 1 c will be left in denominator. Okay, so just simplification. Dear students, we are not explaining this portion because this is school level mathematics. If we explain these steps in detail, it will amount to wastage of time. Okay, so this has become 10.0 kilo electron volt. Okay, to this extent our answer is 100% correct, but it is our discretion that we have converted this million electron volt into kilo electron volt. Moreover, we can also convert it in simply electron volt by multiplying it by 1000, but we have not done so. Okay, we have taken only one step, we have not taken two steps. Now we are going to find out the Lorentz factor gamma. Okay, gamma is equal to this. This has already almost has been solved in previous part, except that this value has not been finalized. 1.0002. Now E is equal to Lorentz factor gamma into mc square. We have calculated it in the above step, and this is the mc square. Okay, so after simplification it becomes so many million electron volt or so many kilo electron volt. Okay, both answers are 100% correct. It is not necessary to convert a million electron volt into kilo electron volt. However, we have done so. Okay, now we know that total energy is equal to kinetic energy plus rest mass energy. So we have just put the value for total energy and rest mass energy, and from here kinetic energy will be obtained by rearranging these. Okay, so here kinetic energy becomes equal to so many kilo electron volt, and we have converted it into electron volt by multiplying it by 1000. Okay, it is not necessary. Even to this extent our solution is quite complete. Okay, next part B. In part B we have just copied pasted part A. So as in part A, carry on. Okay, here the only difference is that value of V is, instead of 0.02 it is directly 0.2. Okay, so accordingly our answer will change. Okay, so this so here in terms of million electron volt over C, this is this, and in terms of kilo electron volt over C, this is this. Okay, by multiplying it by 1000. This step is not necessary, it is just our discretion. Okay, now we are moving to next part in which we are trying to find out the value of Lorentz factor gamma. So Lorentz factor gamma, it has become equal to 1.0206. Okay, now we are going to find out the total energy. Total energy is equal to gamma mc square. Value of gamma has been calculated above, and this is the value, this and this. So total energy has become equal to this million electron volt, and we have converted it into kilo electron volt. Okay, this last step is not necessary, it is a matter of discretion. Okay, now total energy is equal to kinetic energy plus rest mass energy, and from here we have found kinetic energy, which has become equal to 10.5266 kilo electron volt, and we have further converted it into electron volt. Okay, this last step is not necessary, it is just a matter of discretion. Okay, now we come toward part C. Okay, again copy paste facility being utilized. Here V is 0.90 C, that is to say about 90% of the speed of light. So according to this our answer will change accordingly. So relativistic momentum has become equal to 1.054 816 million electron volt over C, or 1054.816 kilo electron volt over C. Okay, this last step is not necessary, it is just a matter of discretion. Okay, now we are going to find out the value of Lorentz factor gamma, which has become equal to 2.294, and now next we are going to find total energy equal to gamma mc square. Value of gamma has been found out in the previous step, and hence total energy E has become equal to 1.172234 million electron volt, and in the next step we have converted it into kilo electron volt. Okay, this step is not necessary, it is just a matter of discretion. And finally we are going to calculate kinetic energy. We know that total energy is equal to kinetic energy plus rest mass energy, and from this expression we have found the value of kinetic energy, which has become equal to 661.234 kilo electron volt, and we have further converted it into electron volt, which is 661.234 electron volt. This last step is not compulsory, it is just a matter of discretion. This is the end of our problem, this is the end of our video. Till next video, Allah Hafiz.